In this video, I'm going to do a few homework problems. This is homework problem number 7 from section 7.2, if you're in my class. And I'm going to start with this one because this is one that wouldn't require any technique because you should know the antiderivative of cosecant squared. And the reason is because you should know the derivative of cotangent. So just a reminder, the derivative of cotangent is equal to negative cosecant squared. So what that tells us is that this antiderivative should be, so we'll just write down cotangent to start with. But of course, the derivative of cotangent is negative cosecant squared, so we're just going to put a minus there. So this would, you shouldn't have to get to any special technique for this one. This is why it's important to know, your main antiderivatives and derivatives of trig functions and exponentials and all that stuff. Okay, so this one I wouldn't expect any technique. All right, and this is problem 29. Again, the first thing you'll ask yourself is, do I just know the antiderivative of tangent of something? And at least, I don't, and most people don't memorize this one. Then you ask if you can rewrite it in a certain way, and I think you can rewrite this as sine over cosine, and the reason that might be a good idea is because with integrals it's strange because sometimes the simpler they look, the harder they are, but if you write it as an identity, sine over cosine, that actually opens up some ideas in terms of substitution. So I'm going to write this as the integral of sine of 4x plus 2 divided by cosine of 4x plus 2. And this is going to be helpful because, remember, sine and cosine are, derivatives of one another, plus a constant in there somewhere often. But now this will let me think of a substitution idea, because if I let u be that denominator, then du is going to be the derivative of cosine, which is negative sine, and then applying the chain rule, oops, I erased too much. Applying the chain rule, we're going to multiply by a 4. I'm just going to put the 4 where that negative is, times dx. Squeeze it in there. Okay, so now my integral looks like this. I've got a u down here, and there are a couple ways of handling the substitution. I usually like to, I see this now as something I can replace. So that would just be du divided by negative 4. So I can write du, maybe 1 du divided by negative 4, I write like that. And now this integral looks great because we should know the antiderivative of 1 over u. It's the natural log, the absolute value of u, plus c. So this will be negative 1/4 natural log of the absolute value of what we called u to begin with, which was cosine of 4x plus 2 plus c. Okay, so this is a perfect example of using an identity to actually make this simple look, or this basic looking integral, have more parts. The more parts there are, often oddly enough, the easier the substitution can be. Okay, and as one last example, let's do number 37. Again, you look at it, you wonder, do I know this antiderivative off the top of my head? That seems unlikely. It's kind of got too much going on. Can I rewrite it? Yeah, we could rewrite this, actually. Let's try that. I think this integral could probably be done successfully in 2 ways. Let's just try rewriting it. Now, you may not have thought to have done this, but I think if you think to do this, it'll come out pretty clean. So I'm going to rewrite this as let's just focus on what's inside there. Let's rewrite this as the integral of sine of 2t plus 1 divided by cosine of 2t plus 1 times 1 over cosine of 2t plus 1 dt. Let's just see if this results in anything interesting. So now I've got sine over cosine, that's tangent, and 1 over cosine is secant. Okay, now this is actually, so maybe I'll write it in reverse and see if it triggers any memories or any stored knowledge you might have. So now I'm looking at the derivative. I'm actually looking at the derivative of a function you should know, and that is the derivative of secant. So the derivative of secant, remember, is secant t tangent t. This is why, again, it's important to have these derivatives and antiderivatives memorized, because more things will occur to you, and they'll sort of pop out. So we could then go do a u substitution for this problem, but I would be willing to bet we can sort of just figure it out. So I'm going to write this, so we know it's going to be the secant of 2t plus 1. Maybe we'll have to adjust for a constant. Let's see. If I take the derivative of secant of 2t plus 1, it's going to be secant of 2t plus 1 times tangent of 2t plus 1. But because of the chain rule, I'd have to times by a 2. But I don't see a 2 up in the integral, which means it must get eliminated by a 1/2 scalar. All right, so that's one way of doing this problem. I think I'm going to do it again on the next page, because I don't think this is the only way you need to do this problem. Let's take a look. All right, let's call this number 37, take 2. Again, you get to the point where you realize you don't know this off the top of your head. You probably can't do it with guess and check, at least not in any efficient way. So, but you notice there's a sine and a cosine, and they're derivatives of one another. So I'm going to try letting the u be, I'm going to try u substitution. I'm going to let u be cosine of 2t plus 1. And the result of that will be that denominator will just become a u squared. And if I can get this to look like, something over u squared, that'll be nice. So we'll let u be that, and then we'll let du be the derivative. So the derivative of cosine is negative sine. Let's put that negative out in front, because I think I'm going to combine all the coefficients to the beginning. So this is negative sine of 2t plus 1. And then because of the chain rule, I'm going to have to times by 2, so I'll put that there. Okay, so now let's make the substitution. So right now I've got that cosine of 2t plus 1 is u, so this is u squared. And this guy here can be replaced with du divided by negative 2. So I usually maybe write it like this, du divided by negative 2. I usually put the constants out there. Okay, and now a better way to write 1 over u squared for the purpose of taking antiderivatives might be u to the negative 2, because we can undo the power rule. So this would be negative 1/2 negative u to the negative 1 plus c, which equals positive 1/2. Let's just write it as 1 over u plus c, and then we'll replace what we have with a u. So this is 1/2 times 1 over cosine of 2t plus 1 plus c, and this would be 1/2 secant of 2t plus 1 plus c. All right, and if you compare with what we did on the way we did it on the previous slide, you'll notice we got the same thing. So sometimes there's more than one way to do the problem. All right, so these are some homework problems I went over because I think they're probably relevant to what you'd be expected to do if you're in my class or any of my colleagues. So make sure you study them and use them as a guide as you're practicing.